Okay, hello friends. Today in last lecture we have discussed already started the electrostatics. Today again I am discussing the electrostatics. One of the basic concept which is very useful in solving the numerical problems. This is charge distributions. What is the topic here? Charge distributions. Basically, charge distribution is of two types. There are two types. इसके दो प्रकार हैं. First is discrete distribution of charge. This is discrete distribution of charge. What is the discrete distribution of charge? This is the system of individual charges. This is the system of individual charges. This is known as discrete distribution of charge. And second one is continuous distribution of charge. Continuous distribution of charge is also of three types. First is linear charge distribution. This is represented by lambda. Second one is surface charge distribution. This is represented by sigma. And third one is volume charge distribution. This is represented by rho. Now we will see one by one. Linear charge distribution, then next surface charge distribution, then volume charge distribution. Okay. Yes, now this is the first linear charge distribution. What is linear charge distribution? If charge is distributed over length, then it is said to be linear charge distribution. If charge is distributed over length, over the rod, then this type of distribution of charge is called linear charge distribution. And it is represented by alphabet lambda. So we can write lambda equals to charge upon length. What is the unit of linear charge distribution? It is unit of charge is Coulomb and unit of length is meter. So lambda has unit Coulomb per meter. And this is the dimension. What is the dimension of lambda or linear charge distribution? It is L minus 1 AT. L to the power minus 1, A to the power 1 and T to the power 1. This is the dimension of linear charge distribution. It is also called linear charge density. It can be also called linear charge density. You can, somewhere it is written like this. So this is linear charge density. This is the important concept. It can be used in the numerical problems. You can take the screenshot. We will see the next. Okay, second is surface charge distribution or surface charge density. If distribution of charge over the area of the body such as conducting a sphere, then this distribution is called surface charge density. Then formula is sigma. It is represented by sigma, and sigma is equal to charge upon area, Q upon A, and unit of surface charge density is Coulomb per meter square, and dimension will be L to the power minus 2, T to the power 1, A to the power 1, L minus 2, TA. This is the dimension. This is called surface charge density. If charge is distributed over the surface like the plate, like the conducting sphere, then such type of distribution is called surface charge density. Now third one is volume charge density. Now we will see the volume charge density. Yes. The third one, yes. Okay, now third one is the volume charge distribution or volume charge density. If distribution of charge over entire volume of the body such as non-conducting sphere, then this distribution is called volume charge density. It is represented by letter rho. So formula of volume charge density, rho equal to charge upon volume. Charge is represented by Q divided by volume. What is the unit of volume charge density? So charge has unit Coulomb, volume has unit meter cube. So unit of rho is Coulomb per meter cube. And what is the dimension? L minus 3, T to the power 1, A to the power A 1. So L minus 3 TA is the dimension of volume charge distribution. So these three density are very important. Just remember it. We will be using the numericals. Take the screenshot. We will see the very important next topic. Okay. Yes. Now this is the one of the most important and very important topic in electrostatics, and mostly question is asked from here. So very numerical aspect will also begin from here. So you have to well known for law. This is a well known law, Coulomb's law. So first of all we will see what is the Coulomb's law. It is the experimental. Coulomb found it experimentally. By the experiment, Coulomb gave this law. If two stationary point charges Q1 and Q2 are kept at a distance R, then it is found that the force of attraction or repulsion between them is what Coulomb suggested. The force of attraction and repulsion, this force F, is directly proportional to the product of the charges. Here in diagram, this is the one charge Q1, this is another charge Q2, and there is a separation. Suppose there is a separation between these charges is R. So Coulomb found the force of attraction or repulsion is directly proportional to the product of the charges. And next, he found force is inversely proportional to the square of the distance between them. If we will combine the both statements, then F is directly proportional Q1 Q2 upon R square. This is very, very important. And this is the sign of proportionality. And if you replace the sign of proportionality, you need a constant. So here K is the constant. Then what is the formula? This is the electrostatic force F is equals to K Q1 Q2 upon R square. So this is called electrostatic force of attraction or repulsion between the two stationary charges, or it is also called Coulomb's force. So here charge is Q1 is positive, here Q2 is positive, here both charges is positive. So this is the force. This is a force 2-1, means force on 2 by charge 1, force on Q2 by charge Q1, and this is the force F12. This is the force on 1 by the charge 2. So both charges are of similar nature. So F21 and F12 are equal in magnitude and opposite in directions. And this is the magnitude of the force. F is K Q1 Q2 upon R square. And this K is called proportionality constant. So this is a very, very important Coulomb's law. So you have seen what is the law. Force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So it is F equal to K Q1 Q2 upon R square. We will see in detail after this. Take a screenshot. We write something next. Yes, previous I have seen what is the force, Coulomb's force, F equal to K Q1 Q2 upon R square. So here the K is the proportionality constant. In CGS system of unit, the value of K is 1. In CGS system, value of K is 1. Then in CGS, the value of force F equal to Q1 Q2 upon R square dyne. Because what is the unit of force in CGS system? Force has unit dyne. So formula in CGS system, F equal to Q1 Q2 upon R square dyne. And in SI system, for air means previous we have seen there is two charges. One is Q1 and another is Q2. One is Q1 and another is Q2. So in between Q1 and Q2, medium is air. Q1 and Q2 medium is air. So in SI system, for air means if both charges put in the air, then the value of K will be 1 upon 4 pi epsilon naught. And numerical value of this 9 into 10 to the power 9 Newton meter square upon Coulomb square. This is the unit of K. And here a term is 1/4 pi. This is the constant. Epsilon naught is a new term introduced here. What is the epsilon naught? It is absolute permittivity of the free space. Absolute permittivity of free space. And its value is 8.85 into 10 to the power minus 12 Coulomb square upon Newton meter square. So this is the very important formula. This is known as Coulomb's force or electrostatic force. Yes, previous Coulomb's law, and this is the Coulomb's law in a vector form. Here vector form of Coulomb's law. If r cap is the unit vector of r from q1 to q2, then charges are placed at separation r, then force on charge q2 due to charge q1, force on charge q2 due to charge q1 is F21. This force F21, force on charge 2 by charge q1, is equal to 1 upon 4 pi epsilon naught q1 q2 upon r cube vector r. And in terms of unit vector, 1 upon 4 pi epsilon naught q1 q2 r square r cap. This is the formula of Coulomb's law in terms of unit vector. Okay. Yes. Now we will see more about Coulomb's law, some important points regarding the Coulomb's law, what we have to take care of. First of all, the force between any two charges is independent of presence of other charge. Let's see here, there is a two charges. One is Q1, another is Q2. Force between Q1 and Q2, this is force on 2 charge Q2 by Q1, and this is force 1 to force on charge Q1 by 2, on and by. This is the force on Q2 by Q1. This is force on Q1 by Q2. Suppose the value of this force is 2 Newton. I have already told you the value of this force are equal. In magnitude, this is the equal. In direction, these forces are in opposite direction. Now suppose there is a third charge, this is the Q3. This is the negative charge Q3. What will happen? Suppose about the Q1. Q1 will attract the Q3. This force is F31. And Q3 is also attract Q1 by force F13. So the force between Q1 and Q2 is not affected by the presence of this third charge. So this is the first important point. The force between any two charges is independent of presence of other charge. Now second, this law holds for point charges. This formula of is holds for point charges. And third, this law holds over wide range from atomic distance 10 to the power minus 15 meter to many kilometers. Means within that less than the 10 to the power minus 15 meter, it does not work. So from 10 to the range of this force is from 10 to the power minus 15 meter to many kilometers. This is the range of this Coulomb force. Some more points we will see in the next slide. You can write this. Okay. Fourth, this Coulomb's law, this is the important point you have to remember, because from here questions can be asked in NEET and JEE. Fourth, just you have seen, this is the charge Q1, this is the charge Q2. This is charge Q1 and this is the charge Q2, and both charge of same nature. You know that if charges of same nature, then there will be repulsion. What will happen? Repulsion. So this is the 2-1 and this repel by this side, F12. So you have seen this is the force on charge Q2 by charge Q1, and this is the force on charge Q1 by Q2. These forces are equal in magnitude and opposite in directions, and these forces are acting on two different objects. So this follows the Newton's third law. Means this law follow Newton's third law. Newton's third law. This law follow Newton's third law because these two forces F21 and F12 both are equal in magnitude and opposite in directions. Next important point. This is the action-reaction pair. This is action reaction pair. Action and reaction pair. These forces are action and reaction pair. You have to remember, this is very important point. And this is called, yes, this is called, this is the important properties. This law is action reaction pair, and this is called central force. This is called central force. Central force. Because it acts हमने कहा कि कैसा है, ये दोनों फोर्सेस कैसे हैं, ये दोनों एक्शन रिएक्शन पेयर है। तो उसके साथ खास बात है कि एक्शन रिएक्शन पेयर है, बट दिस फोर्सेस एक्ट अलोंग द लाइन ज्वाइनिंग द टू चार्जेस। ये दोनों चार्ज को ज्वाइन करने वाले लाइन के अलोंग ही लगता है। सो दिस इज कॉल्ड द सेंट्रल फोर्स। दिस कैन नॉट बी एक्ट लाइक दिस F12 F21 इस तरह से विल नॉट एक्ट। ऐसा एक्शन रिएक्शन पेयर नहीं है, because it acts along the line joining the two charges. So this is the important. Yes. Next. Yes. Next point is, it is a conservative force. Electrostatic force is conservative force. What is the conservative force? The work done by this force does not depend on the path, and in closed path work done will be 0. So you have to remember, very important point. Very important point. It is conservative force. Gravitational force is also conservative. Okay. Next we will see effect of medium. Actually, we have written the formula previous in SI system. In air, F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. their medium is air. If medium is present between the charges, then this force is decreased by a constant K, where K is the dielectric constant of the medium. Dielectric constant of medium. Means this force reduces in the medium by factor K, where K is the dielectric constant. A formula would be 1 upon 4 pi epsilon naught K Q1 Q2 upon R square. Here epsilon naught K equal to epsilon naught epsilon R epsilon. This is called permittivity of the medium. These are the important about the Coulomb's law. You have to remember all the points. Now we will discuss superposition of forces. That will be very useful in doing the numericals. These are the theoretical aspects. An important point I have discussed about the law of Coulomb's law or electrostatic force. So we will discuss something about the vectors, because without vectors very difficult to do the problems here. Vectors or mechanics plays very important role in electrostatics. Next slide we will see, or we will write some formula of the vectors and we will do some numericals and take the practice on the Coulomb's law. We will take few problems. Okay, take the screenshot. Yes. Yes, this is the principle of superposition of forces. If two or more than two forces acting on the charged particle, then for the net force, use the vector addition of forces. Just this is the concept of vectors. In numerical, you have to find out the net force so many times. So you have to go in the chapter of vectors and you have to use the formula of vector additions. Just for your, I have written, you have to add the two forces. So I have written the formula. Just remember the formula of the class 11 in the vector chapters. Root under f1 square plus f2 square plus 2 f1 f2 cos theta, and tan alpha equals to f2 sin theta upon f1 plus f2 cos theta. So this formula is very useful because in the numerical problems you have to apply the vector addition so many times. Just after this we will take few numericals on this law, then it will be very clear to you. Okay. Yes. Now we will see the numericals. This is the very important topics. Numerical can be asked from here. So you have seen the formula. What is the formula? You have seen F equal to K Q1 Q2 upon R square. This is the questions 2 times came in AIEEE. Minimum force between two charges which is separated by the distance 1 meter. What is the questions? Minimum force. Minimum force. For minimum force, charge should be minimum. For minimum force, charge should be minimum. So for the solving these questions, you have to, there is no charge is not given in the problems. So just you have to use the concept of quantization of charge. In quantization of charge, you have a study, the minimum charge exists, that is the charge of electrons. And separation is given here, that is 1 meter. Then use this formula, F equal to K Q1 Q2 upon R square. If minimum charge, then both charges will be electron, and you know the charge of electron is E. So both charges is E. So K, put in place of Q1 E, in place of Q2 again E upon R square, and R is given there 1 meter. So 1 square Ke square Newton will be the force. So This is the answers. The minimum force between the two charges. Yes. Suppose question came like this. There is an equilateral triangle and similar charge is placed at all the vertices. This is the equilateral triangle. Suppose the side is A. You already know similar triangles having the equal sides. And suppose question came, there is a similar charges having the same sign put on the all the vertices, and find the net force on any one of at any one vertices. Net force on any one vertices. You know how you will calculate this? Because suppose this is the Q, this A, B and C. This force repel this Q1. Charge at A will repel charge at B by force K Q square upon A square. Use the formula F equal to K Q1 Q2, F equal to K Q1 Q2 upon R square. In this problem, here this charge is Q, this charge is also Q. Then using the formula, force between these two charges K Q square upon A square. This is the another charge. This applies the force in this direction. It will be also K Q square upon A square, because charges is same, separation is also same. Then these forces, at this point there are two forces. One is Fk Q square upon A square, another is F equal to K Q square upon A square. Now we have to add these forces. Normally we try to add like the algebra. So forces vector, you have to apply the formula of vector additions. So suppose this force is F1, this force is F2, and this is the equilateral triangle. All angle will be 60 degree. So opposite angle will be also 60 degree. So use the formula. Previously I have written F net. Net force F net equals to F1 plus F2. Add these two vectors. Use the formula F1 square plus F2 square plus twice F1 F2 cos theta. Yes. Just this is same, so take it F, take it also F, put at the place of F1 F square plus F square plus 2F into F cos 60 degree, cos 60 degree, 2F square plus 2F square cos 60 degree. Value of cos 60 degree is half. Put the value half, 2 and 2 cancel, it would be 3F square and answer would be root 3F. Now you can replace F 1 upon 4 pi epsilon naught Q square upon A square. This is the solutions. In the questions, what was the questions? 3 similar charges put on the 3 vertices of an equilateral triangle. So we have to take net force on any one of the vertices. So first of all we have to take force by the C, then force by the A. This is the F1 and this is the F2, and you have to add it by the vectors method, not by algebra method, and you will get the answer root 3F. This is the important questions. Like that questions can be asked. I will take one more questions today. Yes. Suppose questions came, there are 4 similar charges put on the vertices of a square of side A, and you have to calculate the net force on one of the vertices. Then what will you do? Here you have to calculate the force, and these 3 forces 1, 2 and 3 will act on charge at 1, 2 and 3, apply the force here. So first of all individually calculate the force. For 1 charge at 1, force apply the formula F1 equal to K Q square upon A square. F1 force at this vertices 4 by 1, use the formula F1 equal to K Q square upon A square. Use the formula Coulomb's law, because Q and Q becomes Q square, distance is A, so it becomes A square, by Q3, force by Q3, it is also K Q square upon A square, because charges are similar. Q and Q becomes Q square and distance becomes A square. And this is the third charge. This is the third charge. Here frequently mistakes comes, because here distance between the charges would be the diagonal of this square, and it is root 2a. So calculate this force by charge onto F2 equal to K Q square, and this is the distance root 2a square, and it would be K Q square upon 2a square. Now here 3 forces acting, F1, F2 and F3, and we have to add these forces. What will we do? First F1 and F2 is added, and what is the angle between them? 90 degree. So F1 plus F3, we are adding first F1 with the F3 using the formula, same the vector addition formula, F1 square plus F2 square plus 2F1 F2, and cos 90, angle comes here cos 90, cos 90 0, other terms vanishes. So it would be F square plus F square, cos 90 makes other terms 0. So we have not written here. So it would be root 2f. So we have added F1 and F3. And now add in that F2 also. So net force would be root 2f plus KQ square upon 2a square. Root 2f is replaced by KQ square upon a square plus KQ square upon 2a square, KQ square upon a square taking common, root 2 plus r. This is the answers. So this is the very important topics. We will take the numericals in next lecture more. So just practice these questions and read the theory whatever today I have given you. This is the very important. I will continue in next lecture from here. Thank you very much.